the M4A1S Solitude. The factory new supply is 110,000. Total supply, 1 million. But every probability model will tell you the drop rate for factory new is around 3%. That's a 230% discrepancy. So either the database is lying, or every investment guide you've ever watched, and every price currently in the CS market is built on a broken foundation. I have not slept chasing this discrepancy. 3 of those hours were on stream. It was quite boring. Hopefully you didn't tune in. But I found an equation, not a theory, an equation. And this equation will spit out the exact probability that you get a skin in factory new for any gun, any float cap, any range in the game. What it can do, it can help us identify mathematically undervalued, fairly valued, or overvalued skins within the market. And it proves and helps give context to every decision Valve makes in this economy. Because once you see this equation, every decision that makes no sense on the surface makes sense if you dig deep enough. Now I could have kept this to myself, but I'm not, because I love the game and I love math, and I want to share it with all of you. Which leads me to a giveaway. Share this video on X, tag 2 people, and me. Winner chosen in 5 days. That's all. I just want the most amount of people to see this. Now it all starts with the video I made last week on the AK Aphrodite, the new limited edition item in the armory. Now I thought I found a weird bug with the Aphrodite in specific when I saw that none of the Aphrodites dropped fell within the 0.07 to 0.08 range on the float. But someone in my comments pointed out that this isn't unique. It's in fact a trait that every skin holds in the game. Every skin with the 0 to 1 float cap has these same gaps. 0.07 to 0.08, 0.15 to 0.16, 0.38 to 0.39, and 0.45 to 0.46. 4 zones, and if you'll notice, they're on the boundaries of each wear, except for factory new. And these spaces, I'll call them dead zones for the rest of the video, are float values in which no skin can drop. I say drop, because if a gun has a 0 to 1 float cap, but you can trade up to it, you could theoretically trade up to within that range. So the only guns you can look at to verify are the limited edition items, because you cannot trade up to them, or souvenirs. And if you look up any skin you want, take a look at that range, it will hold true. Now what about for other float caps? Does it stay the same? No. Those dead zones are always there, but it scales down with the float cap. Take 0 to 0.7, for example. If we multiply 0.07 to 0.08 by 0.7, we get 0.049 to 0.056. The M4 Solitude is 0 to 0.7, so we can look at that on the database directly. And would you look at that? No M4 Solitudes exist within this range. So we have these gaps that are built into Valve's float system, but that's not the discovery. That's just what set off the alarm in my head. Now here's what most people get wrong. While the case odds are well known at this point, the float odds are not. CS Float posted an article a few years ago that shows the exact probabilities for each wear in the game. On a 0 to 1 float cap skin, the probabilities are factory new, 3%, minimal wear, 24%, field tested, 33%, well worn, 24%, and battle scarred, 16%. The distribution is not uniform. They are only uniform within their specific range. Your odds of getting a 0.004 are the same as the odds of getting a 0.04, but your odds of getting factory new are not the same as the odds of getting a well worn. And so it might be intuitive to think that when the float cap shrinks down a little bit, you just simply take the same distribution just with new endpoints. But that's not what happens. What Valve does instead is takes that entire curve and squeezes it within the range. And that's where probabilities get funky. All of the bars you saw in the original bar graph are in any other float range. What changes is the range in which they cover. So take the Negev Loudmouth, which they showed in their article. Has a float range of 0.14 to 0.65. Now minimal wear typically has a 24% probability, but now that minimal wear sits within the field tested range. So that probability doesn't get you minimal wear anymore. What it does is give you a 24% chance of hitting between the 0.18 and 0.21 float. Meanwhile, 0.16, which is still field tested by the way, has only a 3% chance, because that would be factory new if we stretched it out. So now you see, the percentages aren't tied to the skin's range, it's tied to the original curve. And the only thing Valve does is compress that curve. So the question is, can we predict the probability in which you will get factory new for any float cap in the game? I'm not going to bore you with any of the math. You could DM me and I'll send it to you if you want to see it. I'll just briefly explain it here instead in interest of your time. So we need a few points to get a line going and a graph and then an equation. Now luckily we have some anchor points. We know that when the float range is 0 to 1, probability of factory new is 3%. Cool, we have 1 point. We also have a second point that's not immediately obvious, and that's if theoretically, if the float range was 0 to 0.07, the odds of getting factory new would be 100%, because we know the range of factory new to be that. So now we have 2 points. Let's get a few more so we can determine the actual shape of this line, because we know it for a fact not to be straight. So here's the method very briefly. You take your float cap, let's say 0 to 0.3. Firstly, we compress those dead zones to be within proportion of the new cap. 0.07 to 0.08 is 0.01. We just multiply that by 0.3, which gives us 0.003. There are 4 dead zones in total, so we have a total dead zone of 0.012. 0.06 of that lives in factory new, 0.06 of that lives in minimal wear. Then we take those dead spaces and we subtract from the working range, right? Factory new can't be anything between 0 and 0.07 now. The total values you can get for your float can only be 0.064 now, because there's 0.006 value worth of dead zone in there. We take that factory new minus the dead zones, divide it by the total range minus the dead zones, and we get a number. Let's call that number x. X in this case is 0.22222 repeating. Then we take that number and fill up each range. Factory new 0.064. Minimal wear 0.064. Now field tested range is 0.22. There's no dead zones in it, so it's the full range. We take a proportion of that, 0.09 over 0.22, and we get around 42.8%. Now we know field tested's actual drop rate, 33%, so we take 42% of 33% and we get 14%. Right? We covered factory new and we covered minimal wear, and now we covered field tested, only proportionally though. So we add those probabilities together. 3 plus 24 plus 14.28. And we are left with around 41% probability of getting factory new when your float range is 0 to 0.3. That's the system. So I did it for multiple float caps within the game. The calculations don't have to be necessarily perfect, because we're in a market and nothing's going to abide by this equation perfectly anyway, but I did my best. And when we plot these points, it's not a random scatter, and I've got the golden equation. But first, SkinsMonkey. Today's video has been sponsored by the lovely ladies and gentlemen over at skinsmonkey.com. SkinsMonkey is the industry standard trading forum and marketplace for anything and all things Counter-Strike. 24/7 support and an instant trading system so fast, those Bulgarian overpay goblins are sure to go out of business. Now, if that's not enough incentive, throw my code Mike in on the website for $5 off on your first trade. But if you trade up to $100 on the website, they'll double your bonus from 5 to 10. Now, if you don't have any skins and I just gave you some free game on investment advice, you could deposit money and use the website as a marketplace as well. In that case, my code Mike will net you a 5% deposit bonus, bringing it from 30 to 35%. So go get swagged out, courtesy of skinsmonkey.com. So here are my data points. And here's what they look like on the graph. So we run a regression analysis just to find the line of best fit here. And with a regression score of 0.989, we are left with the golden equation. I will call it the Mike Water9 theorem. It is 1.15 divided by the product of x to the 0.04 power and e, Euler's constant, to the negative 3.43x power. Your x value is going to be your float range. You take the highest and the lowest point, and that is your range. The equation will spit out within a margin of error the probability that you get a factory new skin in a float cap of this range. When your float cap is small, your odds of getting factory new are higher. When your float range is large, your odds of getting factory new are lower. This is intuitive. What's not intuitive is the decay. So there's the golden motherfucking equation. Now what can we do with this? Okay, so let's use the equation on the M4A1S Solitude. Now, when it was in the armory, it costed a $10 equivalence in stars. 25 stars times 0.4, 10. It has a float range of 0 to 0.7. Using our equation, that gives us around a 10% probability of getting an M4 Solitude. As we talked about before in the video, that seems to be true by looking at the database. That means the fair value of the M4 Solitude at a 10% drop rate is $100 in factory new. Right now, it's $30, so technically it's undervalued. Now this is a market, there's demand, there's aesthetic qualities that we cannot quantify via a mathematical equation. But if it was $150, I wouldn't buy it now. If it was $100, I could either buy or not buy. If it's under, I think I would have a rather safe investment, considering it's now discontinued. And what if China pumped the M4 Solitude? If it was under $100 and it had Chinese attention, like it does right now, it's undervalued, it has legs. When it's at 100, it's at its theoretical maximum. That's when I would exit. If it was at 100, well, that's the theoretical maximum. That's when I would exit. If it's over 100, you're in unsafe territory and you're looking to lose money. This one's for my own ego purposes. The Tec-9 Whiteout is the rarest possible skin Valve could make factory new. A 0.94 range, and then applying the Tec-9's off-centered float cap, you have a 0.6% chance when you get a Tec-9 Whiteout for it to be factory new. Every other whiteout in the game, every other glove, 1.5%. The Tec-9 Whiteout is 3 times as rare. Don't believe me? Take a look at the souvenirs. 2 majors, 50 Tec-9 Whiteouts in factory new. The trade-ups are skewing that number to be higher than what it actually is. Told you. And lastly, now we know why Valve changed the trade-up system. The rarest factory new skin to unbox on a normal float cap, right, the whiteouts are an anomaly because they're pushed over, are going to be 0 to 1, 3%. We also know them to be the most valuable trade-up fillers, which means that there's a constantly diminishing supply when people are doing trade-ups, or at least doing trade-ups efficiently and effectively. So now they're not only necessary for trade-ups, they're rare. The equation proves it to be more rare than any other instance of any other gun in the game. Valve built scarcity and utility into the same guns now with the new update. That ain't luck of the draw, that's brilliant economic design. And it's the reason why this economy is better than any other economy in any other game. Everything's 10 steps ahead. This equation maps the entire CS2 landscape in any way you want to think about it. I'm sure there's plenty more applications that I didn't even touch on. So now, what can we do with it? We've modeled it out now. We have it internalized. And what happens when we start taking advantage of these inefficiencies at scale? The market and the market psychology now has a counterparty that knows the value of every skin regardless of what it is on the market right now. And knowing this equation, what can Valve do next? And knowing this equation now, what can Valve theoretically do next? Cheers.